Now we're going to move on to integer division. And you can see that under integer division models, well, I have no models drawn. And that's because, quite honestly, the models that we have done for integers, the charged field and the number line, they all kind of fall apart when it comes to division. They just don't work well. So we're not going to waste our time doing them. What we're going to do instead is we're going to look at the official definition of integer division, and we're going to work our problems using that method instead. So here's the official definition for integer division. It says if a and b are any integers, make sure that b is not 0 because we can't divide by 0. Then if a divided by b is equal to c, that's going to be true if a is c times b. So you see what's happening here is they're using this backwards definition again. They did this with subtraction. They turned subtraction into addition problems. Well, guess what? They're turning division into multiplication problems. Why are they doing that? Because multiplication is easier than division, right? It's like you trick your brain. You go, oh, it's not a division problem. It's a multiplication problem. So c times b would equal a. So we're turning this division into multiplication. So c times b, b times c, c times b, same thing, is equal to a. So I know it's probably a little strange to do it this way, but we need to practice writing out the definition. So if we have 8 divided by 4, if we're trying to figure out what that's equal to, and we want to use the definition, we would say, okay, 8 divided by 4 is some mystery number. So by the definition of division, that means if I go backwards, 4 times c would equal 8. So 8 is equal to these two guys multiplied together. So then you just have to think and just memorize you probably have your multiplication facts memorized, at least the beginning ones. So you go, well, what number would I multiply 4 by to get 8? And of course the answer is 2. So we would know that 8 divided by 4 is 2. You don't have to do any models or anything. You just have to think about multiplication. What would I multiply 4 by to get 8? This is just it all written out. So what about 10 divided by negative 5? Okay, now we got a negative number. These are integers, remember? So if 10 divided by negative 5 is some mystery number, then if we go backwards, 10 would be c times negative 5. So I have to think, what number would I multiply negative 5 by to get positive 10? Well, if you want to multiply and get rid of the negative, you better multiply by another negative. So negative 2 is what we would multiply by here. And so this shows you when you take a positive and you divide by a negative, you get a negative. One more. Negative 15 divided by negative 3. Okay, so we're going to say, okay, negative 15 divided by negative 3 is some mystery number, and then I'm going to think of it backwards. I'm going to say that negative 15 is negative 3 times c. We're going to multiply these together. So that's been the idea, is change all these to multiplication. So what number would you multiply 3 by to get 15? Well, it's 5, but would we make it a positive 5 or a negative 5? Let's see. If we multiply negative 3 by another negative, it would turn positive. So we better keep this one as a positive. And this shows you that two negatives, when you divide them, make a positive. So that's how we're going to do it using the definition of division. So a couple things to keep in mind. Remember, you cannot divide by 0. So like if you have a number divided by 0, well, that's not a good thing. That's undefined. We don't know what to call that in math. If you have a negative divided by a negative, you will get a positive. So a negative divided by a negative, that's going to be positive. The two negatives will cancel. A negative divided by a positive, well, that's going to be negative, right? If they're mismatched, if the signs are mismatched, you get a negative. And if you have a positive divided by a negative, that's going to be negative for the same reason that the last one was. Remember, commutative property. You could probably say those in one statement if you use the commutative property. So when this, just like with multiplication and division, if the signs match, you get a positive answer. If the signs are mismatched, you get a negative answer.